This presentation is about WireShark. This is for the course CGS 5131 at University of Central Florida. My name is Rick Lineker. So let's take a minute and give a 10,000 foot overview of what WireShark is. Well, it's a packet sniffer and protocol analyzer. It is open source, which means you don't have to pay for it, and if you want to, you can even modify it. One of the nice things about WireShark is that there is an API that lets you write your own software and take advantage of their libraries. And it is the latest version of what used to be known as Ethereal. Ethereal was really the original open source packet sniffer. So we're really not going to cover networking. This isn't much of a networking class. I could do a networking introduction, but I think I'd pretty much fall short. If you don't know networking, then I'm not sure how much good I would do you. We're not going to talk about an IP address or a port. Now you'll pick it up. You should be able to, if you're challenged in these areas, go ahead and go to YouTube and just look at some stuff. A MAC address. Now the difference between an IP and a MAC address, obviously IP address is logical and assigned by the server. MAC address is physical and stamped into the network card. We're not really going to talk about routers, and we're going to do a lot of capturing, but basically capturing is looking on the wire and grabbing all the packets that go by. So installing WireShark is really easy. Let's talk about it now, because you're going to have to do this in order to do your lab. There's an underlying technology that you're going to have to install in addition to WireShark. It's WinPCAP. That's for Windows build. Now Mac and Linux have their own things, but for Windows you're going to install WinPCAP. And essentially this is a low-level driver that talks to the network card so that WireShark is abstracted from the low-level hardware layer. That way WireShark can concentrate on sort of looking at packets and protocols and stuff, and WinPCAP can focus on actually accessing the data from the network card. Separation of concerns, as they say. So here's the website, wireshark.org, and there's a big button that says Get WireShark Now. It's pretty hard to miss. They actually have training and things you can get on this website. They have documentation for the developer API, which is really nice. Like I said, you can actually, it's extensible. You can actually take advantage of their libraries and go ahead and develop your own software. You could pretty easily hook into WireShark and or WinPCAP and develop your own sniffer pretty easily, especially if you had some sort of a need for a specialized sniffer. Now WireShark does just about everything you're probably ever going to need, but there might be a time when you have some specialized need and it's really not that hard to do. So this is kind of what WireShark looks like on a really simple level. You notice, we'll talk about all the control mechanisms, but this just gives you an overview of what you're going to see. You see every packet has a line, and they're color-coded so you know what the packet types are. In the next pane you have sort of the details you can drill down to. And then the last pane is the actual data that's in the packet. Okay, and notice that you have, it's kind of like WinHEX. You have both a hex part of it and the ASCII part of it. So the HEX window, obviously everything is in hex, and it would be really helpful if when you're using WireShark you had a calculator that could do hex decimal conversions because it may come in handy. So you have the file menu up there. The nice thing is you can save your captures, and there are quite a few options that we're going to look at in just a few minutes. So that's where the menu bar is. The button bar is basically shortcuts to a lot of the functionality. So if you don't like menus, you can actually use almost all the time. The button bar is going to give you, everything you need. The status bar is down at the bottom, and it's going to give you quick information that you need to know. So this is a really nice user interface. It's kind of old school. It's not the typical Metro style that we're getting used to now, but still it's very functional, and it's still very well thought through. So the status bar is going to give you information that comes from the drill downs, and it's always going to change depending on what you're drilling down into. So before you start using WireShark, you need to consider where you're actually going to tap into the network and how you're going to look at the network. So there are some considerations you need to take when you decide where to put WireShark on your network. So as you can see, this is kind of a simple representation of the network. There are lots of different places you can plug into, and where you plug in makes a big difference in what you see. So I know there aren't many hubs left in the world. Hubs are a sad lot, but a hub is everybody sees all traffic. So if you are plugged into a hub, you're going to see everybody's traffic as long as you're set to promiscuous mode. But you may not be in a plug, and then if you're in a switch, which most of us are going to be, then you are only going to see the traffic that's directed to you. You're only going to see the traffic you're only going to see the traffic that comes your way. Now, it might be traffic directly to your IP address, or it might be a broadcast, or it might be NetBIOS messages or whatever. But say if you're George, and say John sent a message to Susie, you're not going to see it. Okay, so that's kind of the downside to a switch. So that's going to be that's going to affect your decision where you plug in. Okay, so there is a switch. So there are switches with a span port. If you potentially can get a switch with a span port, then you're good to go, because then you'll have a destination span port where you can hook your sniffer up and you'll see all traffic. So that's really the way to go, is to see if you can find a switch with a span port. The other thing you can do is use what's called a tap. And a tap is similar to a switch with a span port, except it doesn't function as a switch. Its only purpose really is to tap in and look at the traffic. It will look at all traffic. So why would you use a tap? Well, it's because physical layer errors aren't seen by span. Okay, so a tap is going to actually see more than a span. Span ports increase the CPU on your switch. Okay, timestamps are more accurate when using a tap. Span ports hide jitter, which might lose synchronization. And this might be a really important factor, is after 50% port utilization, you begin to drop packets. They're non-intrusive, and of course it makes you look really cool. Now, there is a software alternative to using span ports and taps, and that's to do what's called an ARP poison. And obviously I can't go too much into detail, but basically what happens is you can actually, as you're monitoring as you're monitoring, you can actually poison the ARP cable. And when you do that, then the network thinks you're the switch. And then when you're functioning as the switch, you get all the packets. And it's a really bad performance hit on your computer and on the network. So it's not a good thing to do on a regular basis. Your network card can easily get overloaded, which is going to really mess up the network. Also, people can find out. I mean, a network, if you're trying to do it clandestinely, a network admin can actually determine that you're poisoning the ARP cache. There are tools to detect that. So this is a picture of a tap and how it might hook up. Okay, here's what I was talking about, ARP cache poisoning or ARP cable poisoning. And your sniffer is going to be plugged into the switch, and it's going to poison the ARP cable. And then the network is going to think that you're the switch, and all traffic will go to you, and that way you'll be able to get all traffic and determine and capture all packets and determine what's going on. So I mean, it's a really good method. Now WireShark doesn't do it, but Cane Enable does, and there's another tool called EtterCap that does. So there are tools you can use for this. So this sounds funny, but it's something you need to do. You always need to set WireShark and make sure you're set to promiscuous mode. That way you can capture everything that your computer can hear, whether it's intended to you or not, whether it's destined to you or not. So you always need to make sure you're set to promiscuous mode when you're sniffing the network. So before you do a capture, you have to select the interface that you're gonna capture. And when you do that, when you go to the menu and select that, it will show you what devices you can capture. Obviously, it's probably not a good idea to capture the VMware device, but the Intel card that you see there is what you're going to want to capture. So let's go ahead and take a look at a live demo here. So there are lots of capture options, and normally I don't mess with most of them unless I'm doing something special. Notice under capture files, it can give you a place to type in a file that it's going to save the captures to. Bear in mind, for a lot of traffic, this will create a very large file, and it will definitely slow your computer down. Okay, so here I've got WireShark running, and it just came up in the splash screen left. One of the really nice things about WireShark is you can see it lists all of the network adapters it found. And in my opinion, what's especially nice is it shows you which ones have traffic. For instance, you can see there's pretty normal traffic on the local area connection. A lot of times, computers like mine have a lot of different types of devices that get listed. And notice that there are a number of these that are flatlined, so you know that those are just either things that aren't connected, like my wireless network connection isn't sort of hooked up. The Bluetooth network connection is not hooked up. So I like this feature that I can see what I've got traffic on. Obviously, what I'm going to do is select the local area connection. Okay, not too much coming in. See, even at an idle, your network is going to have traffic for broadcasts and multicast listening and things such as that. And as I pointed out before, you can actually see whatever packet you want. If I click on a packet here, the line for a packet, so it's going to be reflected down here. So anything I want to see, I can just click on and then see all the details. Now if I want to drill down here, I can. For instance, if I want to drill down here and I can see the interface ID and information about it, time and date and so forth. And then that way I don't have to drill down. It's really nice because before it used to just give you everything in one big window. Now you can sort of selectively figure out what you want to see. Okay, notice that this window is getting more and more data in it. Okay, and it's going to continue to build data. Okay, and I'm not doing anything. It's not like my network is active. But let's go ahead and go to a website. We'll go to that world famous website, ricklineker.com. Let me just minimize that. Now let's see what we can see here. Okay. So I'm going to turn this off, because if I don't turn it off, it's going to continue to go up to the top. So you can actually see the traffic and what happened. So let's go ahead and see what the IP address is for my website. So it's ping Rick. Okay, so it's 50.63. Let me write that down. 50.63.196.51. Okay. So now let's see if we can find that anywhere. Find anything in this list. And here we go. So this is actually quite a bit coming off of the website or related to the website. Let me go on up to the top here. What's really nice is it's got it in green, so you know it's part of some sort of web request. See, WireShark is a really well thought through tool. So there's that same IP address. Here's the same IP address. So this is actually where it kind of starts. Okay. So we can sort through here and see if we can make sense of any of this. You can actually see down here, it's got content from the website, parts of the content anyway. Okay. The best thing for me to do would have been to actually save this as a capture. Okay, and I know this website, so I'm recognizing a lot of content from it. But this is a really good way to get the whole nitty-gritty of a website. Okay. All right. So we're going to go back now to the slide. So I am completely sure that you noticed that very quickly it had captured quite a few packets, and they were all different color-coded, so you know they're for different purposes. The problem with WireShark, unless you really are managing it, that the data will overwhelm you. Okay, so what you need to do is have a way to selectively ignore traffic. If you're looking for stuff coming in from a website, you don't need the NetBIOS traffic or the multicast and stuff like that. So right now, let's take a few minutes and talk about how to selectively ignore traffic. So here are some examples. You can capture only packets that are destined for host 10.1.11.24. So if that's your IP address, you can only capture those if you want. And the reason that will be useful is it will miss a lot of the broadcasts and the sort of network traffic. Or you can select two different hosts, 192.168.0.1 or plus 10.1.11.1, so forth. You can also filter on TCP port HTTP. What that means is you're only going to get port 80 traffic, TCP port 80 traffic. You can filter on a source IP address, such as I could have filtered on my website, the IP address of my website. I could tell it no broadcast, no multicast, and I could actually even filter on an Ethernet host or a MAC address. So the way you do this is you can actually type in these things if you know the codes, but the best way to do it is there's a capture filter editor. And this is in the capture options. You click on capture filter and it gives you everything that's available and you go through and you configure it the way you want, and then it narrows it down so you can only see what you're looking for. Okay, so the newest data is going to stay cached, so you can look at it, and the oldest data will go to your hard drive, so you can look at it later. Okay, so back to the capture options. You can actually split this up into multiple files. Notice that the file specified here is cap1.pcap, but multiple files is actually specified. So you can tell it how big each file is going to be, where it says next file every however many megabytes. Ring buffer with 2 files. So you can also stop the capture after a certain number of packets or a certain size, whatever. So it's very, very powerful the way you can configure it. Okay, you can also go to the details of the actual capture interfaces. And you can actually view the receive and transmit buffer size. And this is actually going to have a lot to do with your performance and how much you're able to hold. Okay, this is going to give you statistics. And for me, this is just a matter of sort of curiosity. I've never ended up using these interface detail statistics for anything. But all this information is there for you to look at, and you would probably want to capture these and make them part of your report if you're using this for some sort of an investigation report. So here is where we left off. Okay, so let's pick this, TCP or UDP, port 80. Okay. Now we'll hit start. You notice there's no traffic at all until I go and hit refresh on my website, and then all I see is stuff that either comes from my website or comes from related IPs. So this is a really, really good way to filter, and I can go through and try to find some of the stuff that happened. Okay. Here you can see HTTP, which means it's a web page or some sort of a web resource. Here it says image.jpg. So if I pull this up a bit, Adobe Photoshop, let's see. Okay, this is another JPEG you can see. Notice JFIF, which you're familiar with. Okay, so there's the JFIF signature. Anyway, this is how you look through these packets that come off of a web server. So I'm going to go ahead and stop this now. So you can actually view and set the protocol hierarchy. So this is one of the options under the statistics menu. And this is showing you what the hierarchy is. Okay. And in this way you can actually follow a TCP/IP stream once it's been started. So let's take a look at that now. Okay, now you have to bear in mind that a lot of files that are going to come off the web server or from any network source are going to be larger than a packet can hold. Packets are in convenient sizes so that in case the NetBIOS has to retransmit them, that it can do that without like retransmitting a whole 1 or 2 meg file. So we need a way to easily track through and sort of follow these things. And what I'm going to do is try to find an initial HTTP request. Here we go. So here's an initial HTTP request, which that's the HTTP header, which is always going to precede any kind of resource. Notice here it says TCP segment of a reassembled PDU. Okay, so now if I right click here, I can say follow TCP stream. And what it does is it puts everything together for me so that I can actually see what it looks like all in one big block. This is really, really nice. So let me go ahead and see if I can find a JPEG. This may take me a second, bear with me. Okay, so here's a PNG. And we'll go ahead and follow this as a TCP stream. We could follow it as an HTTP stream. Okay, so let's see what happens when we follow it as an HTTP stream. Okay, now you actually have the binary data down here. So this is going to actually help you follow this through as far as you can do some of the same kind of data carving things that we had done before. So if you really want to dive deep, you can get expert info on any part of this. Okay, and this will give you quite a bit. Remember we said that frames many times can be resent. This is actually going to keep track of different things that you don't necessarily see when you're looking at just the regular captures. Okay, such as a bad checksum where the frame has to be resent. So you can also do quite a few conversions with WireShark. So you can actually look at conversations in WireShark, different conversations between different devices. So this is actually going to show you the IPv4 conversations. So notice address A and address B, source and destination. You can see I/O graphs. Okay, which is really nice. It just lets you know if there's traffic coming in over part of your network infrastructure. So you can also get flow graphs. Now you're drilling down really to a lot of detailed information, which most people don't normally do, but this might help you track something down. Okay, so here we're going to get some expert information. This is actually quite a bit of information and is going to help you figure out exactly what is going on with this packet and related packets. Okay, and as we talked about before, we can see conversations. Obviously, since I've filtered the heck out of this, we don't have many conversations. Basically, the conversation is between the web server and us. I/O graph. Again, fairly simple just because we've got it filtered so heavily. And there actually is quite a bit here that you can use to help you track down what you're trying to track down. So let's do a bit of exporting. Here, let's export this. And we should go up to File, Export. What we're going to do is we're going to export specified packets. Actually, we're going to export objects, HTTP. Okay. Here, let's go ahead and save all. And I'll just make a folder here. Exports. Save all. So I can go ahead and save the actual data. So for your labs, what I'm going to ask you to do first, obviously you have to install WireShark, and this is platform agnostic. You can install either Windows, Linux, or Mac versions. But I'd like you to go ahead and go to this website, www.malware-traffic-analysis.net/training-exercises.html. And I'd like you to pick 5 of these labs, any 5 that you'd like to do, and go ahead and do them as either a Word document file or a PDF, and then zip all 5 of them up and submit them to the web course. So that will be your WireShark labs for this week.